So, welcome to looking at equivalent expressions. So, follow along in your handouts. For this topic, we are mostly interested in being able to apply our skills with fractions and our skills with expanding and simplifying, as well as factoring expressions and applying our knowledge of fractions to functions and things that are written with function notation. So one of the prerequisite skills that we're going to need to be able to say, are these two functions the same? We're going to need to practice our expanding and our simplifying. So I'm going to invite you to oh, that's okay. Just change this a little bit. There's one skill that I want to review. Add a squared to this bracket for me, if you don't mind, please. Okay. And so now let's simplify this expression by expanding and collecting like terms. So one thing that I've noticed is this vocabulary around what am I doing with these questions. We want to take a look at this vocabulary. So here, simplify means this is too complicated. Make it simpler, please. Show it to me in its simplest form. And how do we do that? We're going to expand things, like we can expand this squared, and then we're going to collect like terms. So we'll notice here that we have, after we do this expansion of things into brackets and expanding this into brackets, we're going to have like terms that we then collect. Basically, if I simplify and keep simplifying, quadratics would move towards the standard form, ax squared plus bx plus c. And we're going to be making things as much that as possible. Here, because I've added a squared, we're actually going to end up with an x cubed term. So let's follow this along. Here, I would say the first thing that I'm going to want to do is I'm going to want to expand this 3x into the bracket here. But here, I'm not allowed to expand this 4x in yet. Why not? Why am I not allowed to expand the 4x in the same way with 3x? Why does the squared mean I can't do that? Bedmus, yes, that's exactly it. Bedmus dictates I have to do brackets first. Why can't I do anything inside that bracket, 6 minus 10x?
Because they're not like terms.
That's right, those are not like terms, so I can't do anything in there. There's nothing left to do inside that bracket. But so once that's finished, I just have to leave it in that form and then do my stuff. So here, 3x times 4x gives me 12x squared. I multiply coefficient times coefficient. 3 times 4 is 12. And then I multiply variable times variable. So x times x gives me x squared. And then 3x times 5, negative 5, I should say, that will give me minus 15x. Now, over here, I have said I need to leave that 4x alone and first expand this square here. So I'll have 6 minus 10x multiplied by 6 minus 10x. Why would I want to write that out a second time? Why would I write this as a multiplication instead of just doing it as an exponent? Diego, is that your hand up? Yeah, so why would I want to do it that way?
Maybe just to see like the steps that you.
That's exactly it. I want to be able to see the FOIL. If I try and do this in my head, I might get it right or I might not. I might make mistakes and miss one of these terms. If I expand it, then I can see I need to apply the FOIL rule to that so that I can get all my terms right. Now at this point, once I've written it as a multiplication, would I be allowed, first of all, to now expand this negative 4x into the bracket?
No.
I should do the FOIL first?
Wait, what?
Yeah. Could I expand this 4x in at this point?
No.
Yeah. I agree that I should do the FOIL first. It's going to make it easier. But I could actually expand this 4x in, provided I only expand it into one of the brackets. I'm now at multiplication stage. I've removed the exponent by writing this as a repeated multiplication. Now, this is a chain of multiplication. This is a set of instructions that says, take negative 4x and multiply it by 6 minus 10x, and then multiply that by 6 minus 10x. Multiply this by this by this. And it doesn't matter which order I do that in. Now, if I multiply this 4x in, I would multiply it by 6 and then by 10x, but only by one bracket. Just the same way if I do 2 times 3 times 5 is 30. If But it's 30 whether I do 2 times 3 first, or I do 3 times 5 first, or even if I do 2 times 5 and then multiply the result by 3. I'm always going to get 30, doesn't matter what order I multiply it in. So here, multiply it in the order that's easiest for you. And I would certainly do the FOIL first. It makes it easier. So equals 12x squared minus 15x minus 4x multiplied by the result of this. So I can't collect these. They're not like terms. This is a like term with 15x, but it's being multiplied. So I have to do that multiplication before I do the subtraction. So 6 times 6 is 36. I actually have a math nightmare about that when I was called on in class suddenly. Some of you don't like being called on in class, and I get it. Called on in class suddenly, and I was very tired, and I said 6 times 6 is 36. And then everyone laughed at me, and I didn't know why. And I remember my 6 squared very easily because I have a negative emotion associated with that. Emotion can help your memory. 6 times negative 10x is negative 60x. 10x times 6 is negative 60x. Careful with your signs. And then negative 10x times negative 10x, positive 100x squared. Okay, so now I'm seeing that I should have drawn this bracket a little bigger. That's 100x squared equals. Now I can multiply this 4x in, and it's going to be the negative 4x that I distribute to here, here, and here. I'm going to collect these like terms as well. This is negative 60x minus 60x. Rather than multiplying that by both of them, I'm going to add them together and make 120x. So I'm just going to cross that out and write 120x there. And now I've collected that like term. Saves me a line. So here we go.
Wait, how?
Yeah, minus 120x.
What about the x squared? Oh,
This x squared here? Yeah, that I have to leave alone. There's no like term inside the bracket to collect. So I have 12x squared minus 15x. And now I'm going to do negative 4x times 36. So 36 times 4. Maddie?
I have a question. So why do you write like the 6 minus 10x twice? Can't you just like square it so it'd be like 36? Like instead, like why do you have to write it out twice? Can't you just?
Because when I write it out twice, I'm taking this instruction, which is multiply this thing by itself. And then when I write it out twice, I can see that it's a problem that requires a distributive property twice. I'm multiplying binomial times binomial. And we usually use the language FOIL, first, outer, inner, last. And I remember that I get 4 different terms by multiplying this out, and some of them will collect as like terms. The mistake that I'll often see is people will say 6 minus 10x squared is 36 minus 100x squared. But then they're missing this negative 120x that comes from the outer and the inner. Those 2 terms multiplying each other. So that was a common mistake that I'm seeing on the test. And so that's why I added this to this problem so that we could take a look at how to manage that in our solutions.
Oh, okay.
Yeah. So that's why I added the squared there, because I thought we need to take a look at that. So now I distribute this in. Negative 4 times 36 gives me, sorry?
144.
Yeah, 144. Very good. So this is minus 144x, and then negative 4x times negative 120x. Negative 4, so I multiply coefficient times coefficient and number times number. So here's negative 4 times negative 120, and so that will be positive 480. Positive 480x, and then negative 4x times positive 100x squared. So, and this is x squared here. Yeah, so I multiply x times x gives me x squared, and number times number gives me positive 480. And then I have 100x squared multiplied by negative 4x gives me negative 400x cubed. And now I have one final line where I collect my like terms. And here I might go through with a different color. I could put a color around all of my x terms, like this, just the singleton x's. And those are all of them. And then I could put a different color around the x squareds and collect those. And then there's only one x cubed term, so that's the only one. I can also write these in any order that I like. because it doesn't matter what order I add things and subtract things, so long as the signs follow those terms. The signs follow the terms, then everything is fine. So I'm going to write this one first because it has the highest degree of x. So I would say this is equal to negative 400 x cubed. And then I'm going to add together my x squared terms. So I'm just going to add coefficient to coefficient. 12 plus 480 is going to give me plus 492 x squared. And the negative 15x minus 144x, well, that will give me minus 159x. And that would be done final answer. That's this simplified into its simplest form. Remember I said that simplify is going to move you towards the standard form if you're working with a quadratic. Before we squared that, we were working towards a quadratic. This is a cubic. It has an x to the 3 term. So that's going to determine its size. All right. So this is a skill we need. Simplifying means expanding things using FOIL. I recommend writing squaring a bracket or cubing a bracket. Write that out as a series of multiplication, and you will avoid mistakes when it matters. Another skill that we're going to want to refine in this unit is knowing what the restrictions are on different functions. So if I have a function that's equal to x minus 1 over x plus 2, there is a value that x is not allowed to be because it would break the universe. What is x not allowed to be with this expression here? If x is 0, then I would have 0 minus 1 is negative 1 over 0 plus 2. So I would have, this would be equal to negative 1 over 2. So that would be negative 1/2. Sounds fine to me. If it was plus 2, then we'd have 2 minus 1 is 1 over 2 plus 2 is 4.
Oh, negative 2.
Negative 2, that's right, yes. So we can't have a negative 2 here. Yep. Yep. Okay. So here we know we can't have x equals negative 2. The reason is that would create a 0 in the denominator. And zeros in the denominator of fractions are not possible. If I have any other type of number, like I say, I have 3 pizzas and I'm cutting them into a certain number of slices, or I have 7 pizzas and I'm cutting them in a certain number of slices, it's all fine. Even if I have negative things, like I have a debt of $200, negative 200, and I'm going to cut it into 15 slices so that 15 of us can spread this debt out. Still makes sense. But if I have 0 pizzas, I can't cut those into slices. Or I can't cut pizzas into 0 slices. It's something that doesn't work. There's always going to be some number of slices. So x cannot equal negative 2 here. The reason x can't be negative 2 is because negative 2 plus 2 is 0. So being able to state restrictions, and we do that with these types of expressions. X is not equal to something, or my variable is not equal to something. This is what we're going to do when we're stating restrictions. How about with a function like this, where I have a binomial times a binomial on the bottom that's already factored, and I can see its factors very clearly. What are some things that x can't be here? Alina? Yes, x is not allowed to be, so we say x is not equal to negative 2 and 3. And for style points, write them from least to greatest. There. For style points, you can write your restrictions from least to greatest. So here Alina has identified that negative 2 would create a 0 here. That's not allowed to have a 0 on the denominator, on the bottom of a fraction. And 3 would also create a 0, because 0 times anything would be 0, or anything times 0 would be 0. Yeah. So these restrictions, where are they coming from? We can't allow 0 to be a denominator. We're not allowed to let the denominator of any fraction be 0. So if you want to create a t-shirt that's like math teacher repellent, put 1 over 0 on your t-shirt, and math teachers will have to avert their gaze as you walk by. They will not be allowed to look at you. Cassidy?
So we don't do anything with the top number.
We're not worried about -1 here. Why is -1 acceptable for this fraction?
It'll just be 0.
It would just be equal to 0. Yeah. And it's okay if things are equal to 0. Like I say, I have 0 pizzas. That's okay. But I can't say I took three pizzas and cut them in 0 slices. So when I have the numerator equaling 0, that's okay in most situations. It means the answer is 0. But if the denominator equals 0, that's the point where the universe breaks, and I can't have that.
So every time you ask that question, it's just we do the denominator. We don't do anything with the top.
Yeah, you're just looking at the denominator and saying, what are some of the values that x is not allowed to be? And so you would say x is not allowed to be -2 and x is not allowed to be 3. These are restrictions on the domain of your functions. So you find these restrictions in the denominator, the values that x is not allowed to be. Michaela?
How come you didn't like change the sign on the first one, but you did on the next one?
Oh, here, this is x is not equal to -2.
But it was
-2?
positive too.
Where here? Oh, here. Yeah, so x is not allowed to be -2 because -2 plus 2 would be 0. But here, +3 minus 3 would also be 0. So that's why -2 and 3. One way to do this is you look at this number here and flip the sign, and that will give you your restriction. But you do have to flip the sign. In the same way that we write factored form, so if I write out factored form of a quadratic, we remember that that also tells me the location of zeros. If I have f of x is equal to ax minus r multiplied by x minus s, then I know that this is some quadratic that will have roots or zeros at, this is r0 and this is s0. Okay? So I know that if I can write a quadratic in this way, the negative number r, that gives me the positive coordinate of one of the zeros. R and S would be the output of the quadratic formula if I simplified this to standard form and calculated with my A, B, and C. That would give me my 0. But these negatives tell me flip those signs and get to these numbers. Those signs have to flip to get there. Yes, it did. This is x plus 2, and this is -2 here. Yeah, -2. X cannot equal -2. Yeah. So that's where we get our restrictions on these functions, is from the denominators of the fractions. Can't be 0. So let's take a look at a question like this. If we want to simplify this function, we're going to, Camden?
Well, -4 positive. Wait. I'm looking at this. Never mind.
So this is a set of instructions here. It tells us first, let's simplify this as much as possible.
Wait, what function is that? Is
So this one down here.
that this one?
No, right here.
Oh.
So do you notice anything about this trinomial on the top, Ashani?
I'm just gonna ask, can you move it up a little bit, please?
Oh, sure. There. So does anyone notice anything about that trinomial on the top? Cassidy? Yeah, so we can't simplify it anymore by collecting like terms. That's true. We have x squared plus 2x minus 8. So that's written in the standard form. Ax squared plus bx plus c. Sophia? Sorry? No, this one's not a perfect square trinomial. Camden? We can factor this. So let's see what happens when we factor it. And when we apply our skills of factoring, we can start applying also our skills of fractions and canceling factors top and bottom. So let's do that. F of x is equal to x squared plus 2x minus 8. So if I'm going to factor this, I want to find two numbers that multiply to -8 and add to +2. So let's see if we can find those numbers. So if I have x plus 4 multiplied by x minus 2. Minus 2 and positive 4 are going to multiply together to give me negative 8. The trick here is I know that one must be positive and one must be negative, because that's the way that you create negative numbers when you multiply. You multiply a positive by a negative. And then the larger number will be positive because they add together to give me something positive.
Because 4 subtract 2 is positive 2.
Yeah, that's right. So in this case, when I write it with positive 4 and negative 2, when I do my, and now the trick is, if I go backwards with FOIL, will I recreate this? So x times x gives me my x squared. X times negative 2 gives me negative 2x. Positive 4 times x gives me positive 4x. So positive 4 minus 2 gives me positive 2x. So that, and then positive 4 times negative 2 will give me negative 8. So there I can quickly check my work to make sure when I go backwards that it's the same. This is all still divided by x minus 2.
But 4 subtract 2 is positive 2, not negative 2.
Right.
It's
Yeah, and that's what I have here.
This
is
it's a
This is positive. This is positive.
Oh, why did that look so? I don't know why I thought it was negative.
Oh, I see. Well, that no,
It
that
just really
explains
looked
it.
negative when I was looking
Yeah.
at it.
It's all right. Okay, so now I see x plus 4 multiplied by x minus 2, all divided by x minus 2. Anyone notice anything? Anyone wondering anything at this point? Camden?
cross out the x minus 2.
Just like if I write a fraction like 36 divided by 18, I could say 36 divided by 18. Well, that's just another way of saying 9 times 4 over 9 times 2. And I could cancel out my factors 9 and be left with 4 over 2. But then 4 over 2, I could say, well, that's just 2 times 2 over 2. And there I can cancel out factors 2 to say that's just equal to 2. And you can check on your calculator. 36 over 18 is indeed 2. And we can cancel out factors when we see them top and bottom. It's the same here, but now our factors that we're allowed to cancel just got more complex. We can cancel out these binomials. However, before we cancel this out, we must remember that there are some limitations on the domain. This is the function f of x is equal to x plus 4, but x is not allowed to be what number?
4. Negative 4.
2.
X is not allowed to be 2 because we saw x minus 2 showing up on the denominator here. So that creates a limit where we're not allowed to have that number on the bottom. All right. So now we've been asked this question. Are these two functions equivalent? Let's see. How high can I get that up here? There we go. That's great. So here is one function. G of x is x plus 2 over x plus 3. And here's f of x. And we want to know, are these functions equivalent? Are they the same thing? So in order to determine that, I need to simplify this as much as possible. So we should already be looking, do we see trinomials that will factor? Once they factor, do we see factors that we can cancel out? And another trick that you could use if you're getting this type of question on a test is you know that you'll probably see these factors turning up in here. So let's see if we can factor this. Camden, you have your hand up.
X minus 4 x plus 2.
Yeah, so this would factor into x minus 4 multiplied by x plus 2. It's the same trinomial as we had over here, but the sign here is reversed. So that tells me I'm looking for two numbers, multiply to negative 8, but add to negative 2. So when I see two negatives, and I see the same thing in the bottom here, I know that one of the signs must be negative, one must be positive, and the larger factor is negative. And this is going to be divided by, how does this one factor? X squared minus x minus 12. Ashani?
Would it be x minus
Yep. Because negative 4 times positive 3, those are going to multiply together to give me that negative 12. And when I add negative 4x and 3x, that would give me the negative x there. Great. So now I notice that I can cancel some factors. So what would I cancel here? Aiden.
The x minus 4.
These x minus 4s will cancel top and bottom, that factor. However, it still gives me restrictions on the domain. So what restrictions would you say f of x has? X cannot equal negative 3 and 4. Yeah. So is f of x the same thing as g of x? Here, what is x not allowed to be? X can't be negative 3. But that's the only restriction to g of x. Otherwise, f of x is the same thing as g of x. So you could say f of x equals g of x. However, f of x has an additional restriction of x can't be equal to 4. Now what these restrictions look like is if you have a line and x can't be 4, then you would put a little open dot there at the point x is equal to 4. And otherwise it would look like that line. So you just see an open dot on your restrictions if you're going to be graphing these. But this is the information that you're going to need to be able to go through the textbook practice problems on page 83 and questions 1, 5, and 6, ACE all. Yeah. Any questions before you practice some of these questions? Max?
Yeah, under why could x equal 4?
So x can't be 4 because before we canceled this factor, it was there.
If you cancel it, so why?
The restrictions to the domain still apply, even after the factor has been canceled away. So it's like it leaves an imprint on the function that it does change it somewhat. So go ahead and get started on your work, but I'm going to show you an example in Desmos of what it's going to look like when you have a function like that. Shawnee? Sure. Let me do a little Desmos demo, and then I'll come back, and I'll come circulating.
Will there just be a gap in the...
Yes. Yeah, I'll show you the gap right now.
We can then.
Certainly, Julie.
And slowly like... Oh, that one you just crossed out. So it's...
Let's say I
X
write a
is
line,
equals
y
equal
equals
negative
3x minus
Is that it?
2.
You
Oops.
simplified it by doing that. That's pretty simple. Also,
You could
you do
Desmos
this?
it or something, or you can just, let me take a look at that in just a moment. But now I'm going to multiply this by x minus 1 and divide by x minus 1. Okay, so now I have this line, y is equal to 3x minus 2. I want this in brackets. Darn. Let me write that again. There. So here's my line, 3x minus 2 multiplied by x minus 1 over x minus 1. If I look for this point, x is equal to 1 here, and I come down, notice that at that point there, when I investigate it, it says 1 undefined. It has a single undefined point there at 1, 1. See that, Max? I have a line, y is equal to 3x minus 2. So here's its y-intercept at minus 2, and it has a slope of 3. And otherwise, it behaves just like the line you would have studied in grade 9, 3x minus 2. However, it has an extra limitation that x cannot be 0. There's one value that's eliminated from the domain of this function, and that's x cannot be equal to 1. It's hard to show, but if I put in x is equal to 1 there, this line, and I show you the intersection, oh, there is no intersection. It goes through that point. If I trace along here, there is a point undefined there. One undefined. There is no, this line does not exist at that point. There's an infinitesimally small hole in the line at that one value of x.